Okay, this is the third geometric series example that I'm going to do, or the third video, and then there'll be one more. I did real simple ones, I did a moderate one, this is a little bit harder, and then I'm going to do one about where this formula comes from. So it'll be four altogether today. Okay, so here's the problem. Here's my geometric series. I need to figure out what this equals. So I'm going to do this a couple of different ways, but first I wanted to get a sense of what this series was. That's what it looks like. Pretty straightforward. But the problem is it starts on 2. So here's method number 1. I'm going to write it this way. This is going to be equal to the full geometric series minus k equals 0 and k equal 1 term. Right? If I start at 2, that's the same as starting at 0 and subtracting off the first 2. So what this will do, this will allow me to use this one. So I'll continue. Don't do anything to this one yet, but I will in a sec. There's my A, there's my R. Now I have the k equals 0 term. So I get 3/4 to the 0 plus the k equals 1 term. So if I write this whole term out, I subtract the first 2 terms, I'm going to start with that term right there. So here's what I mean. This is just an aside. If I start writing this out, k is equal to 0, I get 3/4 to the 0, k is equal to 1, plus 3/4 to the 1, k is equal to 2, 3/4 to the 2, k is equal to 3, 3/4 to the cubed, k is equal to 4, 3/4 to the 4. That goes on, and then I subtract out these 2 terms. 3 times 4/5 to the 1, to the 0, minus 3 times 4/5. Cancel, 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 cancel. Same. Okay. So I just wanted to convince you of that. Now what I want to do, however, is go from here. Okay, I'm going to continue from there. So I'm going to put a box here because I'm not going to use it. I just wanted to show that these 2 things were indeed the same. So this is equal to k equals 0, infinity, 3 to the 4/5, k minus 3 minus 12/5, right there, 12/5. Okay. So now I can use this. A is equal to 3. R is 4/5. So I get 3, 1 minus 4/5, minus 3 minus 12 over 5. This is going to be 3 over 1/5, minus 3 minus 12 over 5. That's going to be 15 minus 3 minus 12 over 5. That's 12. 12 minus 12/5 is 60/12 minus 12/5, and that's going to be 48 over 5. Oops, let me scoot that over again just a little bit. So let me go through that calculation again. I get this, that's going to be using the geometric. I get this, minus 3 minus 12. Write that out. 5 minus 12, minus 12/5, 60/12 minus that. I get 48/5, and that's my answer. Okay, that's one way to do it. Now I'm going to do this the same way that I did the moderate example. I'm going to write out the terms of the series. I'm going to get a geometric series, and I'm going to figure out what my R is and go from there. So we saw that this was equal to 3/4 squared plus 3/4 cubed plus 3/4 to the 4th. Well, actually, I'm going to do the factoring trick. I'm going to factor out the first term. So I get a 1 here. 3 out of 3 gives me a 3. Here I subtract 2. I get a 1. Factor this out of this. The 3 gets factored out. Factor out 4/5 squared, 4/5 to the 4th, and I get 4/5 squared. Okay, So this is going to be equal to 3 times 16 over 25. This is going to be sum k equals 0 to infinity. Sorry, a is 1. I'm not going to write that. So this is just going to be 4/5 to the r. So here I'm saying r is 4/5. A is equal to 1. So this is 48 over 25. This is going to be equal to 1 over 1 minus 4/5. That's equal to 48 over 25, 1 over 1/5. 48 over 25 times 5, cancel. I get a 5 in the bottom, and I get 48 over 5, which was the same answer that I had before. So you have two ways to do it. Write the whole series and subtract off the right number of terms. It's one way. Or write out the series and factor out this. And you could do it a third way. You could figure out what R was and what A was and do it from there. But I like this way better for here. Okay. So we're going to do a more complicated example, and that'll be it for video number 3. Okay. So here's what I get. It's kind of confusing. Nothing's matching up. You're not starting on the right place. The powers don't match up. And so what I do is I write out a few terms here just to give you a feel for it. And what I'm going to do is I'm going to get a 9 here. I'm going to get 6 to the 4th. Notice it's 7 squared cubed, so I'm going to get 49 cubed. Okay. Then I get a 9 here. That's always going to happen. And then I get 6 to the 5th. Remember that's a plus 1 is up here. And then I'm going to the bottom, I'm going to get 7 halves to the 4th, so I'm going to get 49 to the 4th. And then the last one, 9, again, I forgot the square, 6 to the 6th. And I get 49, 7 squared to the 5th. So I get 49 to the 5th. Okay, I'm going to do my trick where I factor out the first term. I get a 1. Obviously, I get minus 4 here. I get a 6 here. Minus 3, I get a 1, so I get 49. Factor out the 9 there. I get 6 minus 4, that's 2. 6 squared. Here I get 49 squared. And I keep going. This is going to be equal to 6 to the 4th over 4 times 9. I'm sorry, 49 cubed. Sorry, I wrote that really. Let's try that again. I got 9, 6 to the 4th times quantity 49 cubed. R is 6 over 49. Remember, I can write this is equal to 6 over 49 squared. And so I get 9 times 6 to the 4th over 49 cubed. And I'm going to get, oops, that's a k. Remember, here's the k equals 0 term. Here's the k equals 1 term. Here's the k equals 2 terms, and it's going to continue. So I get 1 over 1 minus 6 over 49. I get 9 times 6 to the 4th times 49 cubed times 1 over 43 over 49. That's going to be 9 times 6 to the 4th times 49 over 43 times 49 cubed. Cancel, I'm going to be left with a 2 here. So I get 9 times 6 to the 4th on the top. I get a 49 squared times 43 on the bottom, and that's my answer. It's perfectly okay to leave it like that. So again, this is a harder one. Numbers are bigger. I started at 3. So what I did is I wrote all the terms out. This is the method that will always work, even though it's harder. I factor out the first term, and I get a geometric series, a standard geometric series. That's always going to happen. And then I realize that R is 6 over 49, so I write it as a geometric series. And then from here on out, I'm just using the formula. This times this with the formula, and I continue. Okay, let me know if you have any questions.